Unit 1B, Lesson 4, Constraints and Rearranging Formulas. What we talk about in this lesson is going to be very similar to what we talked about in the previous lesson. We're going to take situation scenarios and find the equation that best represents, models that situation. And then we're also going to take equations and rearrange those formulas, those equations, to isolate a given variable. Now to the first example. A typical cell phone plan has a fixed base fee that includes a certain amount of data and an overage charge for data used beyond the plan. A cell phone plan charges a base fee of $62 and an overage charge of $30 per gigabyte of data that exceeds 2 gigabytes. If C represents the cost and G represents the total number of gigabytes of data, which equation could represent this plan when more than 2 gigabytes are used? So the first thing I'm going to do is try to eliminate some of the equations based on the information we're given. The information I'm going to start with is the base fee of $62. So no matter how many gigabytes you use, you for sure have to pay $62 for that plan. In the equation, that is going to be the constant, the number by itself. So if I look at equation 1, the constant is 30, and the same thing for equation 2, the constant is 30. So those two equations cannot work. The flat base fee of $62 is going to be the constant. So now we've narrowed it down to equation 3 or 4. If we look next at the next piece of information, there's a charge of $30 per gigabyte of data that exceeds 2 gigabytes. That's going to be the rate, which would be the slope of the problem, which in equations 3 or 4 are the same. Okay, so that part of those equations is correct. The next part is going to be the expression within the parentheses. So the only difference between 3 and 4 is that inside the parentheses in 3 it's 2 minus g, and in 4 it's g minus 2. So we have to determine which one of those is arranged correctly. One thing we have to remember in this equation is we're looking for the equation that represents gigabyte usage over the 2 that we're given. Okay, so the easiest way to figure this out is just to plug a value in that is greater than 2 to see what happens to those two equations. So let's just pick 3. If we would plug 3 in for g in the third equation, we would have 2 minus 3, which is negative 1. Negative 1 times 30 is negative 30. 62 plus negative 30 is $32. So that means that the cost of your plan, if you use more than 2 gigabytes, would actually go down. Okay, that obviously does not make sense, so equation 3 probably is not going to work. Let's plug 3 into equation 4. We would have 3 minus 2, which is 1. 1 times 30 is 30. 30 plus 62 is 92. That seems more reasonable. Okay, so it would be equation 4. That would model the cost of this cell phone plan. So use the information, eliminate some of the equations that you can. When you have it narrowed down, a thing you can try to do is plug in some values into the equations to see which one actually works. So the next example, an electronics store sells DVD players and cordless telephones. The store makes a $75 profit on the sale of each DVD player, represented by lowercase d, and a $30 profit on the sale of each cordless telephone, lowercase c. The store wants to make a profit of at least $255 from its sales of DVD players and cordless phones. Which inequality describes this situation? So if you look at our choices 1 through 4, all of them are arranged the same way. The only difference or change is the inequality symbol. So you have to determine which inequality symbol best models or represents this situation. And the key part is the store wants to make a profit of at least $255. Okay, so if we look at equations 1 and 2, looking at those inequality symbols, that's saying that our sales of DVD players and cordless telephones, if we take those results together, that is going to be less than $255. That is not what we want. We want a profit greater than $255, or at least $255, which means equation 2 is not going to work as well because that's simply just equal to. It's less than or equal to 255. So now we've narrowed it down to 3 and 4. We have to determine whether at least means greater than, or does it mean greater than or equal to. So if we want a profit of at least $255, that means it can be equal to $255. That's just the bare minimum profit we want to make. So the correct equation in this case is going to be equation 4. 75D, so $75 per DVD player, plus $30 per cordless telephone. Those total sales must be greater than or equal to $255. Example 3. Students were asked to write a formula for the length of a rectangle by using the formula for its perimeter. P equals 2L plus 2W. The perimeter is equal to 2 times the length plus 2 times the width. 3 of their responses are shown below. So we have equation 1, equation 2, and equation 3, just different ways they isolated to get L, the length by itself. So we want to determine which responses are correct. So off to the right, I've gone through the process of how we can take our original equation, P equals 2L plus 2W, and rearrange it to get L isolated by itself. So first thing I would do is subtract 2W to the other side. So we would have P minus 2W, P minus 2W equal to 2 times the length. The next thing to get our length isolated by itself is divide by 2. So if I divide by 2 on the right, have to divide by 2 on the left. There's understood to be a 1 in front of the P. It's just if that's a 1, normally we never write that in there. It's understood. So I have 1 divided by 2, which is where my 1/2 comes from. That multiplied by P. 2 divided by 2 is 1, which is why this simplifies down to just W. So we have 1/2 times P minus W equal to L. And if we look at our options 1, 2, and 3, option 1 is what we have simplified over to the right. So we know for sure option 1 is going to work. Also, if I look a step above, if I erase this 1, where I have P minus 2W divided by 2, that is option 3 up above. L is equal to P minus 2W divided by 2. It's just that option 1 is actually a little more simplified. Now we have to determine whether or not equation 2 is an equivalent way to write this formula for the length of a rectangle. The only difference between 1 and 2 is that if we would use the distributive property and multiply 1/2 through to both these terms, we would get 1/2 times P, which is 1/2 P. 1/2 times negative 2 would be minus W. So equation 2 would work as well. So out of those 3 equations, all 3 of them work. They're just written in slightly different forms. Now to the last example, the formula for the volume of a cone is V equals 1/3 times pi times the radius squared times the height. The radius R of the cone may be expressed as, so we want to rearrange this formula to get R isolated by itself. Okay, so what I want you to do is pause the video, see if you can figure out how you can isolate to get R by itself, and then start the video to see how I go through the process. The process you went through might be slightly different than what I went through. Just compare and see to make sure that you got the same thing in the end. So the first thing I would do is get rid of this 1/3 factor in front. So we could either divide by 1/3 or multiply by the reciprocal, which is usually easier. The reciprocal of 1/3 is 3. So I multiply both sides of the equation by 3, which left me with 3V equal to pi times R squared times H. Now if I'm trying to get rid of or isolate R by itself, I'm multiplying by pi and H. So I can do one step. You could take this in 2 separate steps, but I just did this in one step. We would divide by pi and divide by H. Do that to both sides of the equation. So now we would have 3V divided by pi H equal to R squared. Now to get R isolated by itself, we have to get rid of that squared. The inverse operation of squaring something is taking the square roots. We would have to take the square root of the right and left side of the equation. When we take the square root of a quantity squared, we have to account for the positive and the negative result. In this case, since we're talking about the radius of a cone, that's talking about a distance. Distances are going to be positive, so we can ignore that negative out in front. So our final equation is going to be r equals the square root of 3v divided by pi times h. So the main thing you need to take from this lesson is being able to take information, a story problem, and take those values, those quantities, to create an equation that models that situation. Also need to be able to rearrange formulas to isolate a certain quantity or variable. And then also need to talk about constraints. So constraints referring to, in this problem, we were talking about gigabytes of data if we use more than 2 gigabytes. So this is referring to the constraint. We can't have gigabyte usage less than 2 gigabytes for this particular situation.